Ready.
All right, so what we're doing right now is simulating a phase loss outage. We got 8 inverters. This is building 1777, and we're going to simulate the phase outage. We're going to look at the currents, total kW of everything, and basically walk you through that process. So first thing I want to show you is right here on the tablet. Total production is 302.6 kW. We have our stopwatch also ready here. First I want to show you the currents of the multimeters. So right now on phase A, you got 357. Phase B, we have 355. And then phase C, we have 356. I want to explain two things before I throw this phase. Is that the first one is that when I throw a phase and the inverters stop producing, that restarts an internal clock inside of the inverters. That clock is set to 8 minutes. Protocol for Minnesota is to start after 5 minutes. Xcel's requirement is to start before 10 minutes. That's our time frame. Again, when I throw this phase, it's going to actually restart the inverters when that clock starts. So if I throw this phase right here from this disconnect and we're to leave that for 5 minutes and then throw it back on, the inverters are actually going to start at 3 minutes. They're going to start producing at 3 minutes. That's the big requirement, is production. We don't want to see production. So say if it got to 8 minutes, that clock actually starts over. All right, I'm going to throw the phase right now, and we're going to watch all the values. So we look at the multimeters right now. Currently on phase A, which is the phase that's thrown, we have 0 amps. On phase B, we have 2.5 amps. On phase C, we have 1 amp. If we go over to the tablet, stopwatch has not started yet because I have not put back on the phase, but we have 0 watts. This is production for the whole site. So whether we wait 5 minutes or 7 minutes, again, that just subtracts it from that 8-minute startup time. Again, Minnesota code is that it has to start after the 5 minutes. So we're going to just run this as if we already verified that there's no production, and I'm going to throw the phase back on, and then we're going to start the stopwatch. All right, phase is back on, and stopwatch is started. With phase restored, one thing I want to show you over here is that this is power draw from both the grounding transformer and the inverters. Each inverter right now is drawing 0.25 amps. So each phase you're looking at about 10 amps. And this is not production, and we can verify that on the computer right there. It shows 0 watts, last updated a few seconds ago. And again, we waited about 30 seconds before that phase restored. So 30 seconds subtract 8 minutes, or 8 minutes subtract 30 seconds. We should see the inverters kick on, start producing at about 7 minutes and 30 seconds. they're starting to ramp up. That's good. Yeah, so you can see right there that it's starting to ramp up. You can see it both on the tablet there as well as on the multimeters. They ramp up at about 25% per minute. So full sun, you should be kicking out around 450 amps. So yeah, it's ramping up right now. So that's the way that we would have liked for it to go during witness test today, but with a 5-minute delay that the inverters then started up at 3 minutes. And again, if it gets to that 8-minute clock, it actually restarts that 8-minute clock again. So you wait till 9 minutes, that's going to give you 7 minutes for startup for inverter production. Yeah, that's what I got.